Hey everyone, welcome back. In this lesson, we're going to continue talking about the things that we did in the last couple of lessons, where we were talking about basic operations involving fractions. So a few videos ago, we talked about how to add proper fractions and how to add mixed numbers. And then after that, we talked about how to subtract proper fractions and how to subtract mixed numbers. And then we talked a little bit about multiplication and division as well. Now, since we spent maybe a little bit more time on the addition and subtraction, when I do practice examples of that, I'll do it a little bit faster than we've done before. And then when we get to the multiplication and division, I'll try and slow it down a little bit while we're going through those examples there. So my plan for this video is this one is just going to be practice problems. I'm going to go through at least one addition, one subtraction, one multiplication, and one division problem, and then after that I might throw up a couple more onto the board, some easier examples, some harder examples. We'll start with addition. We'll just go in order based on how we discussed each topic, but what I'm going to do is I'm actually going to keep this almost exclusively in the domain of mixed numbers. So we're not going to be talking about examples with proper fractions very much in this video, just because that's sort of the easiest case. I want to give you examples involving the hardest case, and then if we've got some time at the end, then we'll do some of the easier ones as well. So we'll start with just going through, we'll do an addition practice problem. Practice problems. Yeah, so everything in this lesson is going to involve just mixed numbers, and or almost entirely mixed numbers. And then for the addition and subtraction problem, what I'll do is I'll solve it one way right now, and then maybe if we have time at the end, I'll solve it the other way as well. So if you remember, for addition and subtraction, I showed you two ways to deal with that. One is to convert all of the fractions into improper fractions, convert all of the mixed numbers into improper fractions, and then go from there. The other one is to deal with the whole numbers separately and deal with the fractions separately. So I'll go through it one way, and then we'll see how we're doing for time, and we'll try and come back and do the other way as well. But so let's get started. We're going to try and add these two mixed numbers together. So we've got 2 and 3/7, and we're going to try and add that to 1 and 13/14. Alright, so that's the plan for this problem. We're going to try and add these two things together, and I'm going to do it with the method of dealing with the whole numbers separately and dealing with the fractional components separately. So the first thing we need to do is get a common denominator. Regardless of how you choose to solve the problem, that's something that you need to do. You need that common denominator. Now, I should point out that that denominator doesn't have to be the lowest possible denominator that's out there. It's just more convenient for you if it happens to be the lowest common denominator. So you could, multiply 7 by like 20 and multiply 14 by 10, and it was like, oh look, that'll give me a common denominator, let's use that one. You could, but you're making life harder for yourself when you want to work through the rest of the problem if you have an unnecessarily large denominator. So what we're going to do instead is we're going to try and find a common denominator for this 7 and 14 using the method that we've been talking about, which is to find the lowest common multiple of 7 and 14. Right, now if I just go through and show the work for the lowest common multiple, you might have already figured it out because I sort of designed this question to be simple that way in terms of finding what that common denominator is. But if we look at this, we divide out the smallest prime number, that's going to be a 2, that leaves us with 2 7s there. We put a 7 over here, and that's going to leave us with 1s down there. So our LCM is going to be 2 times 7, which is 14. So now we know that our denominator, the denominator that we want both fractions to have, is that 14, right? So what we're going to do is we're going to rewrite this line that we've started with, but I'm not going to put in the fractions yet. I'm going to put 2, and I'm going to put that line for the fraction. We're going to put a 14 on the bottom. We need to figure out what goes on top, right? And then for the second one, I'm going to do the same thing. Now, with the second fraction, you'll notice that I haven't changed the whole number. I haven't changed the whole number for either of them, but I also haven't changed the denominator for that second one. You don't have to do anything to that second fraction to get the denominator of 14, which means that if I can just carry that denominator down to the next line, I can do the same thing to the numerator. The second fraction doesn't need to be changed at all. So now I've got that fraction is complete, but I need a numerator over here in this fraction. So to do that, we're going to look at what we started with, which was a fraction of 3/7. That's what we started with, right? We had 3 over 7 is equal to, and we want it to be something over 14. So I have that line for the fraction. I'll put a 14 on the bottom. We want to know what goes in the numerator. So if I look at the denominators that I have, to get from 7 to 14, I have to multiply by 2. Now, in order for this to be an equivalent fraction, if I'm multiplying the denominator by some quantity, I have to multiply the numerator by the same thing. So if I multiply the denominator by 2, I also have to multiply the numerator by 2, which means that I'm going to get an answer of 6 up there. 3 times 2 is going to give me 6, and that's the 6 that's going to go over here in my mixed number. So now, this second line here is what we're working with. 2 and 6/14 plus 1 and 13/14. Right, so now we want to add these together. If I want to deal with just the whole numbers first, that's going to be 2 plus 1, which we'll write down in the next line that that's 3. But so we've got 2 plus 1, and then we also want to deal with these fractions. So I'm just going to put the fractions over there and the whole numbers over here. So that's 6/14 that we have right here. It's going to go over here. So we've got 6/14, and then we've got this 13/14 as well. Let me get rid of some of these arrows just because I think it's getting a little bit messy. So that's what we have now. There, and I'm going to get rid of these lines down here as well. So I've just rearranged that second line. To get it down to the third line, I've just put the whole numbers next to one another, and I've kept the fractions together as well. So now I can just do the addition for these whole numbers right here, this 2 plus 1, right? And then I can do the addition for those two fractions over there. So if I go ahead and let me do it up here, just because there's more space. If I do this up here, we'll get 2 plus 1 is going to be 3, plus, and then if we go and add what we have here in this fractional component, we got 6/14 plus 13/14. Altogether, that's going to be 19/14. Now, that's a little bit of a problem because when we are writing mixed numbers, we never want an improper fraction there. The whole point of the mixed number is so that you don't have to deal with any improper fractions. So we want to convert this improper fraction right here into its own mixed number, and then we'll combine both of those into our answer. So to do that, we need to figure out how many times 14 goes into 19. I was going to say into 9. So we need to figure out how many times 14 goes into 19, which is 1 time. So I'm going to keep that 3 from before. We've got 1 time. And then if you remove 14 from that group of 19 that you started with, you'd be left over with 5. And so converting 19 over 14 into a mixed number, you should get 1 and 5/14. You could also do this problem with long division. So if you remember, you ask yourself, how many times does 14 go into 19? It goes in once. We're going to subtract 14, and we're left with 5. That 1 over there is our whole number. This 5 down here is our numerator, and that 14 over there is our denominator. All the pieces of your mixed number are embedded in the solution to that long division problem. So now we're just one step away from the final answer, which is to combine our 3 over here with that mixed fraction over there. So to do that, we're just going to add the whole numbers again. We've got 3 plus 1 is 4, and then we've got 5/14 left over. And that would be your answer to this addition problem. Alright, so addition, I mean, normally when you're dealing with addition of just whole numbers, it tends to be simpler than subtraction, and you got to be comfortable with both of those in order to do multiplication and division. But when it comes to fractions, I think multiplication and division are easier than addition and subtraction, just because you have to put in so much work to get the common denominator sometimes that the fractions can get kind of messy. Whereas with multiplication and division, you end up dealing with smaller and smaller numbers in the middle of the problem, and then sometimes your final answer comes out to be much larger. But I think in terms of working through the problem, multiplication and division are easier. So don't get too flustered if you're struggling with the addition and subtraction for fractions because you think it should be easier. In my opinion, addition and subtraction of fractions is harder than multiplication and division of fractions. And also with mixed numbers it gets harder as well, right? So there's our example for addition of mixed numbers. Your test questions and assignment questions and things like that won't ever really get more complicated than that. Just single digit whole numbers attached to not overly complicated proper fractions, and you just have to add those two mixed numbers together, or addition and subtraction, things like that. So let's move on to a subtraction problem. So let's do 3 1/6 minus 2 1/4. Now, our first step is that common denominator, right? It's the same idea as addition. The only difference is when you actually get to the addition part, it's a subtraction problem, so we don't add, we subtract. But everything else, process-wise, is the same, except for that little borrowing thing, which we'll get to. So we want the LCM in this case. For our common denominator, it's going to be the LCM of 6 and 4, which, if we go through the math, we'll get 6 and 4. Draw that. We've got a 2 here, a 3 there, a 2 there, 2, 3, 1, 3, 1, 1. And so our LCM should be 12, which maybe you figured out before, but if not, then your LCM, the denominator that we want as our target, is going to be 12, right? 3 times 2 is 6, times 2 is 12. So that means I can rewrite this line, and it's going to be 3 and something over 12 minus 2 and something over 12. Now, we want to turn the two fractions that we started with, we want to turn 1/6 and 1/4 into something over 12 and something over 12. So if we look at 1/6 first, to turn this into something over 12, we look at those two denominators. What do you multiply 6 by to get to 12? Now, of course, it's 2. 6 times 2 will give us 12. Whatever we do to the bottom, we also have to do to the top, which means we get 2/12 up there. So that means that this 1/6 can be rewritten as 2/12 over there. Now, in your denominator, we have the same idea, but instead of a 6, it's a 4. So we ask ourselves, what do you multiply 4 by to get to 12? And that is going to be 3. So whatever we do to the bottom, we have to do to the top as well. We do 1 times 3, and that will give us 3/12. So that way, we've converted both fractions. We've converted 1/6 into 2/12 and 1/4 into 3/12. And so now we're almost ready to go ahead and do the subtraction, but if we do it the way that I think is the easiest way to do it in terms of keeping the numbers reasonably small, which is that dealing with the whole numbers separately and the fractions separately. If we do it that way, then you have to do that borrowing thing, right? And the reason we have to do that borrowing thing is that right now I only have 2/12 of a pizza here in, you know, individual slices, and someone's come into my my pizza shop and asked me for 3/12 of a pizza, and I can't give that to them. I have enough pizzas to satisfy the whole order of 2 and 3/12, but I don't have enough individual slices here to match the individual slices that the customer wants, right? So in order to do that, I need to take one of my whole pizzas, my uncut 3 whole pizzas, and I need to chop it up into, I need to break it up into 12 different pieces so that I can, so that I have enough slices to give the person who's asking for them. So basically what I do is, because this fraction is smaller than that fraction over there, I'm going to take this 3 and I'm going to put a line through it, I'm going to put a 2, right? And what that's letting me do is now I've taken away one whole from what I've started, from what I started with, but I'm not allowed to just take away one whole from the fraction that I started with, because then I'm just changing the question. So if I take it away here, I turn that 3 into a 2, I have to put it back somewhere else. And so the way I put it back is that in this fraction, instead of letting it be 2/12, I make it 2/12 plus 12/12. 12/12 is a whole. So if you add in, you just next to your numerator, you put in a little plus sign. I'll make it a little bit larger for now, but if you put in a little plus sign and then whatever number your denominator is, put that same number up there, you're accounting for the number that you're cutting out here. So 3 and 2/12 is the same as 2 and 2 plus 12/12, which in the next line, of course, we can simplify that. Right now, this is getting a little bit messy up here. So what we have is, instead of 3 wholes, we have 2 wholes, and then 2 plus 12, that's going to be 14, and our 12 as a denominator, that stays. So now we've rewritten 3 and 2/12 as 2 and 14/12. And then from that, we want to subtract 2 and 3/12. Alright, hopefully that's making sense. So now from here, because the whole number here, we're able to subtract 2 from 2, and we're able to subtract 3/12 from 14/12. So we can just go ahead and do that subtraction now. 2 minus 2 is 0, so I can just put that 0 there for now. You don't really need to. 14/12 minus 3/12, that's going to leave us with 11/12. Now, if you're writing a mixed number and the whole number is a 0, you don't need to write the 0 like that. We can just make it a proper fraction and just write it as 11/12. You don't need to write that 0 in front. Alright, and so then you should get this answer of 11/12. So the borrowing thing can get a little bit confusing, but the more you practice it, the better you'll get. So if you are looking for extra practice questions, then if you just look online, type in subtracting fractions problems with answers so that you can check your work to see if you're doing it right, and then just try some of them. You can try them with both methods. This is one method which some people tend to find easier. I grew up converting the fractions into improper fractions, which it's a fairly straightforward process, right? We talked about how to convert mixed numbers into improper fractions. So if I was doing that, I could do that conversion first. I would turn this 3 and 1/6, I would make that 19/6, and then 2 1/4 would become 9/4. And now I would just find my common denominator, and then I would just do the subtraction without much trouble. So that's the other way to do it, but then you have to still find that common denominator. Now you're going to end up multiplying this by something, and you have to multiply that by something as well. So down here we were dealing with smaller numbers. We never got to any number bigger than 14 in this problem, but up there you're going to be dealing with 19, and then you have to multiply it by 2, or in a different question you could be multiplying it by 4 or 5 or 7 or something. So that's why I showed you this method, because that one sometimes leads to larger numbers, whereas this one, although it requires a little bit more work on your part to work through that borrowing thing, you end up dealing with smaller numbers. Alright, hopefully the addition and subtraction questions are making sense now, so we'll move on to multiplication next. And let me see what I have written down for that. So, we're going to do, this one is where we include one mixed fraction and one proper fraction. So now we've got 2.5 times 3/5. Now, if I remember correctly, we never actually discussed multiplication and division involving mixed numbers. And the reason for that is the best way to deal with them is to just convert them into improper fractions, which we know how to do, and then just do the multiplication with whatever you have in front of you. It can be multiplication of proper fractions or improper fractions, works the same way. And if you happen to have a mixed number like we do in this problem, then just, change it into an improper fraction and proceed as you normally would. So to do that, just a reminder, you have this 2.5. We're going to go in this direction. First we're going to do multiplication, and then we'll do addition. So first it's going to be denominator times the whole number, and then we're going to add the numerator on. So to get the numerator of our improper fraction, denominator times whole number, that's 2 times 2 is 4, plus the numerator, that's going to be 5. So that's the numerator of our improper fraction, and the 2 that we had from before as our denominator down there, that just carries over, that just comes along for the ride, and so we turned 2.5 here into 5/2 down there, or 5/2. Alright, and so now we're going to take that, and the second fraction is already a proper fraction, so we're just going to write down 3/5, like so. Now, because we've got these two fractions, no mixed numbers anymore, we could just go ahead and do the multiplication, but I'm going to encourage you to reduce this fraction first, just because it simplifies the math later. Obviously, now we're dealing with reasonably small numbers, but if I gave you numbers like 512 and 128, you could have cut those numbers down into way smaller pieces before trying to do some sort of multiplication with them. So I can't reduce 5/2. I can't divide both of those numbers by anything that they have in common. I can't do that for 3/5 either. I also can't do it for that 3 on top and this 2 on the bottom, but I can do it for those two 5s, right? So I'm going to take those two 5s and I'm going to divide each one of them by 5, which is their highest common factor. Oops. So I'm dividing that by 5. 5 divided by 5 is going to leave me with 1, so I put a 1 there. And same thing down there. 5 divided by 5 leaves me with a 1. So that means if I rewrite this, instead of 5/2, it's going to be 1/2 multiplied by, instead of 3/5, it's going to be 3/1. So now we can go ahead and do that multiplication. To do the multiplication, you just multiply the numerators together, multiply the denominators together, and you'll have your answer. So if we multiply the numerators together, we get 1 times 3 is 3. And if we multiply the denominators together, we get 2 times 1 is 2, which gives us this improper fraction, which you could write down as your answer, but it's always best to, if you have an improper fraction as your answer, convert it to a mixed number, which in this case is going to be 1.5, right? Which you can figure out by the process that we used before. How many times does 2 go into 3? It goes in once, and you're left over with one piece that goes as your numerator. Or you could do long division, and you'll find all of those components of your mixed number in your answer there. So that's another example of multiplication. This time we had a mixed number in there, but just convert it to an improper fraction and you should be fine. If it's easier for you to remember it, you could just stick to the converting mixed numbers to improper fractions for addition and subtraction as well, because then you have to remember less methods, but you should be warned that converting your mixed numbers to improper fractions for addition and subtraction can lead to you working with larger numbers. So if you're comfortable with multiplying, 29 by 47, go ahead and use improper fractions for your addition and subtraction. Otherwise, put in that little extra effort, see if you can master the second way to add fractions together or to subtract fractions, and use that for those two operations, and then use the improper thing for multiplication and division. That said, let's do a division example, and then I'll let you guys go after that because some of the videos have been a little bit longer, so you might appreciate one that's slightly shorter than 40 minutes. So for this one, we're going to do 3 4/5 divided by 1 1/3. Alright, so that's what we're dealing with in this problem. Now, same idea for division as it is for multiplication. We don't want mixed numbers. We want to convert them into improper fractions. So let's convert this first one into an improper fraction. If I write it out the other way, we're going to do denominator times the whole number. If I don't draw it with the arrows, but let me write out what we're doing. So we're doing the denominator times the whole number. That's going to be 5 times 3, and then we're going to add the numerator, plus 4. That's going to be the numerator of our new fraction here. The denominator that we had before was 5, so that's just going to carry over, that's going to go down there. So we've got denominator times whole number, that's denominator times whole number, plus the numerator, plus the numerator. So that first one, we're halfway there to converting it into an improper fraction. Then we put our division sign, and we do the same thing for the other one. Denominator times the whole number, that's going to be 3 times 1, and then we add the numerator, plus 1. And our denominator originally was a 3 over there, so that's just going to carry over, and we put a 3 downstairs. Alright, now let's go and figure out what those numerators actually are. For the first one, we've got 5 times 3, that's 15, plus 4, that's going to give us 19. So we've got 19 over 5 divided by, and then for the second one, 3 times 1 is 3, plus 1 is 4. And our denominator is still a 3. So this is what we're working with now. So we've got 19 over 5 divided by 4 over 3. So if I'm going to rewrite this up here, our next line is going to go up there. Now, we don't actually do the division. What we're going to do is we're going to take that second fraction, we're going to flip it over. We're going to take the reciprocal of it, and then we're going to change this division sign into a multiplication sign. So the first fraction is going to stay the same. We had 19 over 5. That stays unchanged. And then instead of a division sign, I'm going to put a multiplication sign. And instead of 4/3, I'm going to write 3/4, or 3/4. Alright, so now we can check to see if there's anything we can reduce. We can't reduce this first one. 19 is prime and 5 is prime. And we can't reduce that second one. 3 is not divisible by any of the same stuff that 4 is. So we can't reduce anything there. We can't reduce 19 and 4. We can't reduce 3 and 5. So unfortunately, we're just going to have to go out and ground out this multiplication on top and on the bottom. So let's do that. On top, it's going to be 19 times 3. And on the bottom, it's going to be 5 times 4. So on top, that should give you 57. 19 threes are 57 if I've done my math right. And on the bottom, we get 5 times 4 is 20. Now we've got this down to a single fraction. We don't have little operations like those multiplication ones in there. It's just one single fraction. We've got a number on top, number on the bottom. That's an acceptable final answer, but because we like to be as proper as possible, we'll convert this back into a mixed number. And let's go through the long division for this one, just because we haven't done it in a little while. I'm going to get rid of what we started with here, just because I need some space. So it's going to be 57 divided by 20. Now 20 doesn't go into 5, so we move over. 20 goes into 57 how many times? Well, if we count by 20s, we'll get 20, 40, 60. 60 is too big, so 20 times 2, right? We got 20 times 1 is 20. 20 times 2 is 40 is the most that we can fit. So we'll put a 2 up there. 20 times 2 is 40, so we put that down here. We subtract, and we're left with 17. And so here are all the pieces that we need for our mixed number. This 2, that's our whole number. This 17 is our numerator. And the 20 that we started with as our denominator, that just carries over. So we get 2 and 17/20 as our final answer. Alright, so hopefully that's making sense. That's one example of addition, one of subtraction, one of multiplication, and one of division. Our next lesson is going to be on converting fractions into decimals, and vice versa, converting decimals back into fractions. We've already talked about doing, multiplication and division with decimals. Addition and subtraction with decimals isn't really that different from addition and subtraction with whole numbers. We never really covered anything like that. But the last thing that we really need for decimals, now that you guys know how to work with them from our first unit, is how to turn decimals into fractions and how to turn fractions into decimals. So that'll be our next topic, and then we'll have another lesson on more practice problems. Some practice stuff, of course, for the fraction and decimal conversion stuff, but also if you guys want more of this stuff, more of maybe some more complicated examples, instead of just one operation like just multiplication, I might give you a problem where you have one fraction plus another one divided by another one, and so you have to follow BEDMAS and you have to work through both of those separate operations in the same problem. So we'll do some harder problems like that, and then shortly after that we'll have a test review, because we're almost done everything that I wanted to get through for our fractions unit, and then we'll move on to a brand new topic after that. So that's about it for this one, and if you have any questions, as always, you guys have my contact information, so feel free to get in touch with me. Otherwise, I will see you in the next lesson. Have a good one.